All right, everybody. Our next area of study is going to be scientific revolution. Now, a lot of times when we think the word revolution, we think a violent overthrow, a violent takeover of something. And this isn't like, little beakers, a little test tube and stuff overthrowing the classroom or, even our science teachers like Mr. Rawls and stuff, like overthrowing the school. Scientific revolution is going to be a drastic change in the scientific thought of the time period. And we're going to see this big change happen in the 15th, 16th centuries in Europe. Now, the old idea of science back then was all still based off this guy right here, Aristotle. So Aristotle during the the Greeks, and essentially there's the Aristotelian system that's in place yet. Basically took the old Greek and Roman ideas, the ideas of Aristotle especially, and they were kind of tweaked to go along with the Catholic Church doctrine. Basically, we knew that for example, we'll talk about this in a little bit, that the Earth was the center of the universe because it's most important, and that according to the Church, there's a religious reason for that whole thing. We knew how the body worked, and there was a religious reason for that whole thing. Essentially, we know now it was very, very wrong, but at that point, it was taught as and accepted as truth. That this is the way science truly was. And so here's some examples of why we can make this change. First off, the Renaissance is a big part of it. In terms of the Renaissance idea of humanism, we're learning Greek and Latin, we're reading the old texts, and so besides Aristotle's writings, we're getting Roman guys, we're getting other Greek guys like Socrates, like Plato, and we're bringing all these old texts back. And we're like, hey, you know what? Maybe some of the stuff that Aristotle wrote isn't really what he wrote, or in some ways it's actually wrong. And so we need to change that a little bit. The Protestant Reformation, people start questioning, is the church always right? And so some of those questions of the church being always right kind of comes along with part of that as well. We have exploration. A guy named James Cook, a British guy, creates the first chronometer, a device that's used to find where you are by way of longitude on the world. When you're doing exploration stuff, you have to invent and create new technologies as a way to make these explorations happen. So as part of that, you have more and more scientific discoveries happen. You have everyone's favorite class, math as well. Different people in math, especially Simon Steven and James Napier, start doing things with math, start doing things with algebra, geometry, and in the end, math starts becoming this new universal language. In fact, math is a language in a way. Don't tell the math department I said so, but math can communicate. Math can do everything. And essentially, because of these guys, Steven and Napier, we learn how to prove abstract things with logical evidence. And it kind of comes from the idea of mathematics. You can take math and it can be very, very abstract. It can be Pythagorean theorem, whatever, and you can take it and you can prove it. I used to have to do proofs in geometry where you take all these theorems and you have to find ways to prove them. Essentially, we take the world and we use math and we use logical evidence, like through math, to prove that things happen. So, where do these things take place? Let's start with the astronomy first of all. Here's the old idea of astronomy. It was discovered by a guy named Ptolemy. It was the Ptolemaic system. He was a Greek astronomer in the hundreds AD or C, if you will. His idea was basically geocentric, that the Earth was at the center of everything. Here'd be the Earth right here. He said that outside of that, all the other worlds, our celestial bodies, are in a series of spheres outside of us. So here would be like the Moon, Mercury, Venus, the Sun, Mars, Jupiter, Saturn, etc. Going all apart. And there's this big like sphere that they're in. They're kind of this big celestial body, if you will. Not necessarily solid, but they're just kind of out there. Now, the last is this crystalline sphere, and the very, very last sphere right here. Kind of encapsulated, kind of almost like the world is inside a big marble almost. The universe is like a big marble, and the Earth is the very, very center of it. And this outside crystalline sphere kind of helped everything move. And out that was the abode of the blessed, or that was God. And they kind of looked down, controlled everything. That was the way everyone thought astronomy worked up until maybe the 1500s. We started getting new and more ideas. We're going to start with a guy named Nicholas Copernicus. He was a mathematician, and he liked to study the stars. He actually kind of created an idea for a heliocentric universe. He wasn't the first guy. The idea of heliocentric universe actually starts in India, but the first person in Europe to figure it out was Copernicus. And so he used mathematics to look at the position of the stars, position of planets when they're around, And he said that instead of the Earth being the very center, bam, right there, the sun is the center. And then out there, then you have Mercury and Venus and Earth and the Moon and Mars and Jupiter and Saturn as far as they could see. Outside of that, he said, all those little stars out there are all fixed stars that aren't moving at all, and that they're there. Now, we did again, Johannes Kepler took it a step further. Kepler was a German mathematician. He said that instead of being a spherical or a circular orbit, as you see here, it's actually elliptical or oval or egg-shaped instead. And so here would be the sun, here's a planet. So you have different times when the planet is further or closer to the sun. That'd be summer, winter, so on and so forth. And so it's kind of new ideas of the sun being the center of the solar system, or in their case, universe, and the Earth, other planets going around it. Another man named Galileo Galilei took it a step further. He was an Italian scientist, big into math and astronomy. He took it a step further. He was one of the first guys to use a telescope. And in fact, telescopes were only available because of a new science of lens grinding, mostly for glasses, and also for spy glasses to use on ships. But he could grind lenses, grind pieces of glass to make a telescope. He could then see celestial bodies. One of the things he figured out was that Jupiter is not just Jupiter. There were moons going around Jupiter. He also saw sunspots, and he saw mountains on the moon. Basically proving that these celestial bodies out there are not just vapory things out in the world, but they are actually solid. And they can have things going around them. Now, he published his ideas in a book, and he's actually ordered by a church to stop. He basically said, here's the Aristotelian version, Ptolemaic universe. Here's what Copernicus said. Here's what Kepler and me say, and I say, and this is the way things are. Now, he was actually ordered by the church to stop printing this book, and he was called a heretic because he was going against teachings of the church. Eventually, he was put on house arrest, put on trial by the church, and he had to recant or basically take back all things he said about how the universe actually looks. But in the end, we know that what he said was really true about the universe. He also did experiments with gravity as well. And the old Aristotelian idea was that the heavier something was, the faster it falls. So if I took a 110-pound person and a 300-pound person, I threw them both off a bridge, the 300-pound guy was going to reach the bottom first. Galileo didn't trust that. So he went to a city of Pisa, where the leaning tower is. And Galileo stood up here on the leaning tower of Pisa. He took a really heavy ball, think like a bowling ball, and took like a baseball. And he held them out here like this, the Tower of Pisa, and dropped both at the same time. He noticed that both fell the same rate. It didn't matter that you had a really heavy ball and a really light ball, a 10-pound bowling ball and a baseball. They fell the exact same, and they hit the ground at the exact same time. And so in a way here, he actually ended up proving Aristotle and the church wrong again, made him be more angry with them. Now, Isaac Newton took things a step further. Isaac Newton was from Oxford, England. He was a mathematician, actually taught math at Oxford. He kept with the idea of elliptical orbits and used math, especially calculus that he invents, to prove it. And he actually makes 3 laws of planetary motion explaining how planets move. And he actually then later on discovered the universal law of gravity. Everyone knows, thanks to the idea of him, the apple hitting the head, all that kind of stuff. What he actually described was an orbital cannon. You fire a cannonball, all things in space, all things in the world are attracted to each other in some way, shape, or form. That the faster it goes, the farther it's going to go around. The slower it goes, the more it should be attracted to the Earth here. It's kind of the idea of the orbital cannon. But he actually helped use this to prove the idea of heliocentrism, that things should be going around the sun. The sun is so much bigger that everything is kind of going around the sun at a certain speed. And so he helped prove these ideas through mathematics. The other big change we see is in medicine. The old way of medicine was done by a guy named Galen. Galen was a Greek, okay, and he did all of his study of medicine by dissecting animals. He never dissected a human. That was looked down upon. So he dissected animals, cows, pigs, sheep, whatever they had, okay? And he decided that your whole body is regulated by 4 things, okay? 4 fluids within your body regulate everything. You have phlegm, it's like the clear stuff, like when you talk up a loogie, that kind of thing, okay? You have yellow bile, you have blood, which is red, and you have black bile, which is earth. And you had to regulate all these humors in your body to be healthy. When one got out of alignment, that's when things were wrong, and you had to try and fix them. This is where the practice of bleeding comes from. People used to think up until the 1800s, they used to think that when you got sick, it's because you had to replace your bad blood. They would take little knives and cut people on their hand or their feet, whatever, and have them bleed out as a way to replace the blood. Also, Galen, the liver, about right, you right side of your stomach there, uh, pump the blood out instead of your heart. All these ideas were the old way of thinking, and people still thought the liver was the most important organ because it pumped your blood. I mean, the liver is important to, toxifies everything, that kind of stuff, but it was not as important as your heart. Two new guys, Andreas Vesalius and William Harvey, proved them wrong. Vesalius was doing human dissection at the University of Padua in Italy. We know that not Galileo, Da Vinci was doing them as well, but he actually published his human dissections. And so he actually kind of wrote the book on where organs are supposed to go, where organs are supposed to be, and the actual layout of organs on the human body. William Harvey up in England diagnosed the entire circulatory system. He figured out that, hey, the heart is what pumps the blood, and it's one big circuit of how the blood runs all around the body and back to the heart, proving these old ideas wrong through doing human dissections, actually analyzing humans versus just animals. Last is in chemistry. According to Aristotle, the world broke down to 4 elements: earth, wind, fire, and water. The fifth one, too, is kind of what fire is made up of, but that's not a big deal, okay? And they decided the state of matter by if they were cold and moist or hot and dry. So fire is hot and dry. Here's exactly here, okay? So hot's up here by kind of the blood, air, and fire really hot and wet. Right here you have fire and earth being dry, earth being cold, fire being hot. And you have to kind of regulate kind of how everything worked that way. So basically you break down state of matter to 4 things: earth, wind, fire, and water. There was a theory of the atom out there already. Everyone made up a little stuff, but basically saying that all people were made up of these 4 things: earth, wind, fire, and water. The new way, get new ideas, come from Antoine Lavoisier, who basically looked at more than 4 elements and kind of created a current naming system for the elements you guys are studying in chemistry. So you have like antium, amantium, and all kind of different stuff that exists on a periodic table. Because Lavoisier started kind of breaking those down into more and more things. Robert Boyle also figured out that stuff can move and change a little bit. He figured out how the volume of gas runs. In chemistry, you might use Boyle's law, and he used pumps, that were a new technology at the time, to figure out how air pressure worked. He learned that, hey, at 100 degrees Celsius, water boils. But if I put it at 1/10 of normal air pressure, it boils at 46 degrees Celsius. And kind of discovered how that volume of gas, how much is there, varies with the amount of pressure involved. And so it makes a big difference in chemistry. Basically, we're learning new ideas about chemistry and what the world is actually made up of. I think, so why is this whole thing important, guys, all right? Basically, we have new discoveries, which means we have more technology, we can discover more stuff. Microscopes, telescopes, spyglasses, new things for exploration, all those kind of things come out of this. We'll start getting the scientific method out of this. You have done this in science class, hopefully, where you find a problem, maybe how's the heart work? You gather information, you dissect it, look at it. You form a hypothesis, I think it's this. You experiment with the dissection you did. You record your analysis, you record your data, get the conclusion, and repeat to find the answer. Basically, we start using this modern day scientific method, proving things through logic, as a way to prove stuff versus just saying, yep, it's there because God did it, and kind of what the church wanted to do. Also, it challenged the church, kind of shows that secular issue of the time, how things got more secular during this time in history. All right, guys, I want to thank you guys for listening very much. Thanks for watching. This is due Thursday the 13th. We'll have some presentations that day in class as well. You have a test next week, Renaissance through Scientific Revolution. So Renaissance, Reformation, Exploration, Scientific Revolution, test next week on this. Subscribe to me, guys. Watch my stuff. Check the little links within the video. You can look for more information if you want more information on certain topics. Thanks a lot, guys. Appreciate it. Have a great week. Let's do Thursday. Thank you.